Projectiles Inclined Plane Horizontal Landing, 2007. So here we have a plane is inclined at an angle of 45 degrees to the horizontal. And we have a particle is projected up the plane with an initial speed of u at an angle theta. And we have to be careful here. We can see it's highlighted in bold, but the angle is given with respect to the horizontal as opposed to with respect to the inclined plane. We're told the plane of projection is vertical. In other words, it's going straight up the plane and it's not veering to the left or the right. And we're told the particle is moving horizontally when it strikes the plane. And we have to show that tan theta is equal to 2. So again, we're not going to be worried about how we're going to get the tan theta equals 2 until we get closer to the end. Instead, we're going to see, well, what information are we given and what would we normally do with that information. So let's start by drawing our diagram to see what's happening. So we have our plane, the ground, and the plane is at an angle of 45 degrees. And then we have our particle is projected with a velocity of u, and the angle is theta with respect to the horizontal. So that means with respect to the plane, it must be theta minus 45 degrees. And then as it's projected up the plane, it's landing horizontally. So when landing horizontally, we know that if we have two lines parallel and a transversal, then we end up with alternate angles. So therefore the landing angle here is 45 degrees. And we also know in landing that SY is equal to 0. So let's make out our table then with respect to U, A, V, S and T in both the X and the Y direction. So if you pause it and then fill out your table. Okay, so when I have theta minus 45 here, I know that it can often get a bit messy when you're trying to do out cos of A minus B and sine of A minus B. So instead what I'm going to do is I'm going to say, well, there's my angle alpha and there's my angle beta. So I'm going to let alpha equal theta minus 45. And at the end of the question, I'm going to have to remember to sub back in for alpha as being theta minus 45 degrees. I also know that I have 45 there for beta. So sine 45, in other words, sine beta, is equal to 1 over root 2. And cos beta will be cos 45, which is 1 over root 2. And therefore, if I'm subbing in for my u in the x and the y direction, we know that u is equal to u cos alpha in the I direction plus u sine beta in the j direction. So u cos alpha, I'm going to just leave it as cos alpha. I'm not going to put in the theta minus 45 until the end. You can, of course, have it in here right the way through until the end and then simplify. There's nothing wrong with that, okay? It's just sometimes I find students start to try and expand it too soon and end up getting a bit confused with it, okay? Now we know that our gravity has to be resolved. And again, we know that if it's on the inclined plane and we're looking at gravity acting in a downward direction, then when we resolve our parallel and our perpendicular components, well, if this is 45 and this is 90, this angle here is also 45, which makes this 45, which makes this the opposite side, and this one the adjacent side. And again, remember that it was projected up in the air for u, so therefore in the y direction it's going up and in the x direction it's going up. So therefore g is coming down in the opposite direction for the x and the y there, okay? So if we zoom in on that video, you can see the direction of gravity is down, so it's the opposite direction to the y for u, and then in the x direction, g is also going in the opposing direction to u in the x direction, okay? So therefore both negative for g. So therefore this becomes minus g sine beta, and of course sine beta we saw was 1 over root 2. And then y is minus g cos beta, which again is 1 over root 2. So that's going to be minus g over root 2 also. V is equal to u plus at. So therefore we have Vx is equal to u cos alpha minus g over root 2t. And then v in the y direction is u sine alpha minus g over root 2t. S equals ut plus a half a t squared. So therefore we have s in the x direction is u cos alpha t minus g times a half, so 2 root 2 t squared. S in the y direction is u sine alpha t, and again a half times g over root 2 t squared, and then t and t. Okay, so now we have our table. We have every possible equation that we will need for this question. So we need to look at, well, it's landing horizontally, okay, so therefore we know the landing angle up here on the right hand side is 45 degrees, and we also know that sy is equal to 0. So in order to get our landing angle, we know that we have tan L is minus Vy over Vx. And of course, if we look at Vy and Vx, we need t, our time. And if we're looking at Sy equals 0, again, what we can do is actually find our time of flight. So we're going to start with that process. So we're going to say, on landing, Sy equals 0. So Sy we saw there was u sine alpha t minus a half g over 2 root 2. Sorry. So minus g over 2 root 2 t squared. So I'm going to let that equal to 0. I'm going to multiply across by 2 root 2. I'm going to get the highest common factor, which is t. And then they both multiply to give me 0, so that means that 1 is equal to 0. In other words, when it's at the start, the displacement above the plane is 0, so that's obviously at the start. Or 2 root 2u sine alpha minus gt must equal 0. In other words, t is equal to 2 root 2u sine alpha over g. Now, if you have alpha as theta minus 45, then that would read 2 root 2u sine in brackets theta minus 45 over g. Okay, so as I said, both are fine. I'm just going to be working with alpha until the end. Okay, so the next thing that we need to look at then is, what else do we know on landing? Well, we know on landing that the landing angle is 45 degrees. Now, tan of the landing angle is equal to minus Vy over Vx. So what we can do is put in our Vy over our Vx and also work out our time of flight and then equate. Or you could sub in your time of flight here and simplify and try and get out your tan 2 theta. I'm going to get my 2 time of flights and I'm going to equate them. Okay, so that's your personal choice. What did you do in this part of the question? Okay, so L is 45 degrees, so therefore that's tan 45. Vy, if I go back to my table, we said was u sine alpha minus g over root 2. Yeah. Over our Vx, and our Vx, if we go back, is u cos alpha minus g over root 2t. Okay, and we love tan 45 because that's 1. And multiply out the brackets, so it's u sine alpha plus g over root 2t all over u cos alpha minus g over root 2t. So we have a fraction here, so we're going to cross multiply, which gives us u cos alpha minus g over root 2t is equal to minus u sine alpha minus g over root 2t. I'm going to bring all the t's to the left-hand side. So therefore that's g over root 2 plus g over root 2. Or I should say, sorry, that should be a plus there in the previous line, I was thinking. Okay, and then we have is equal to u cos alpha plus u sine alpha. And then t is common there. So therefore we have t divided across by, taking out u as being common also, cos alpha plus sine alpha, divided by, and I have g over root 2 plus g over root 2, which is 2g over root 2. And if I'm dividing by a fraction, I turn it upside down and multiply, which gives me root 2u over 2g times cos alpha plus sine alpha. So this is also my time of flight. So if I call that equation 2 and I go back to my other time of flight and I call that equation 1, well, both of them represent the same time when the particle is landing. So therefore what I'm going to do now is I'm going to equate 1 and 2. Okay, now if I equate 1 and 2, well, I have 2 root 2 u sine alpha over g. So 2 root 2 u sine alpha over g. And that will equal our second equation here, root 2u over 2g times cos alpha plus sine alpha. So root 2u over 2g times cos alpha plus sine alpha. And then if I cross multiply there, I can see, well, g's are gone, u's gone, root 2 is gone. Okay, and then what does that leave me with? Well, it leaves me with 2 sine alpha is equal to cos alpha plus sine alpha all over the 2 here. And if I multiply across, that gives me 4 sine alpha equals cos alpha plus sine alpha. Bring over the sine, and that gives me 3 sine alpha equals cos alpha. Now, of course, if I divide both sides by cos alpha, that gives me 3 sine alpha over cos alpha is equal to 1. And what's sine over cos? Well, it's tan. So therefore that's 3 tan alpha equals 1. In other words, tan alpha equals a third. Now, this is where we start to look at what is it that I'm trying to get. Because clearly that's tan alpha equals a third. And if I go back to the question, I can see it's tan theta equals 2. So this is where we now have to introduce the fact that we have alpha is actually equal to theta minus 45. Now, of course, if you've stuck that in at the start, you'll have almost gotten your answer right now at this stage, okay? So I'm going to say, but alpha equals theta minus 45. And I'm going to sub that in now. Okay, and therefore this is going to become tan theta minus 45 degrees equals a third. And of course we know in trig we always write a and b over our angles. So we're going to go to our tables and find where is tan a minus b. And tan a minus b is of course tan a minus tan b over 1 plus tan a tan b, and that is of course page 14 in your maths tables. So let's go on to the next page then and see what have we got. Well, we have tan theta minus 45 equals a third. So instead of tan theta minus 45, I'm saying tan a minus tan b all over 1 plus tan a tan b. And that equals 1 over 3. Tan 45 is, of course, 1. And if I cross multiply here, I'm going to have 3 times tan theta minus 1 equals 1 times 1 plus tan theta times 1. And therefore that gives me 3 tan theta minus 3 is equal to 1 plus tan theta. Bring all the tans to one side and I get 2 tan theta is equal to 4, and yay, we have tan theta equals 2, which is what we wanted to show. Okay, so let's have a look at our breakdown of marks. What are we getting for this question? So this was a 25 mark question. we go back to the start, so we had 25. And the first 5 marks were for getting our time of flight. So we had 5 for our time of flight. We then had 5 for getting our Vy and our Vx. So if I go back here, so we had 5 for our Vy and 5 for our Vx. So we were getting 10 in total for those 2 equations. So 5 for the one on the top, 5 for the one on the bottom. And then we had another 5 for getting our tan theta minus 45 is equal to a third. And then we had 5 marks for getting out tan theta equals 2. So we had 5, 10, 15, 20, and 25. Okay.